Hello, welcome to another Blue Lightning software looking at C# in Unity development stream. What I wanted to do actually is, this is carrying on from the previous Invoke versus task. I just want to actually reveal how we got this to work. Here it is. Look, it needed this line. Cut it short. What was happening? It was kind of how I suspected. But the way it was before, it was doing this. Whoops. It was doing where was it? This was the previous setup. It was not doing this. It was doing this. So it was await the delay. Delay was a separate task without Complexio. So maybe I should just recap. Okay, this is the previous attempt. And now we're examining the overhead differences between a task and Invoke. Let's have a look. What I was expecting was what we will see soon. We've got a complex factor. Now previously it was doing this one time. Okay, so alright. This is now press play. Okay, so this is 1 times a kind of just a multiplication squaring thing. Mildly complex task. See, they're quite similar. There's a bit more call. This is calling the tasks. This time of completion is a bit more time to completion. Where they level up a lot. I mean, that would expand outwards. If I had 100,000, you'd get 10 times this number, but this would stay similar. What it's saying is very little overhead in the Invoke actually running. Yeah, it was like 50 milliseconds for that many more of these. However, if we increase the workload a fair amount, let's have a look. That levels it up quite a bit. So let's have a look. They just become really similar given the current setup. These are a bit more. These are about the same, similar-ish. You know, there's still a bit quicker there, but the work kind of equates. The work being done by Complexio here, because we've made it do a number more times, set of iterations of what was the original. Do that 10,000 times now, and it becomes a noticeable chunk of work. But it's still this odd theory that they're about the same. So it just makes me think, wow, that is not multi-threading as it was. That the task is not on a new thread. It can't be. It's creating Invokes running on the same thread. Okay. How could it be the same? Because they're both just running on the same thread. We looked in the last one, setting it as this delay, doing this task delay within this task, as this was the previous video. You can see this wrapping it up in an async task itself using this task delay. If it was just this task delay like that, yeah, if you do that and put the delay number in like 500, what you wind up with is that will lock the UI thread. So like this, yeah, doing it within its own thing. Sorry, this would have been having it like this. This gets it off the UI thread for the purpose of this delay. Now, what I started messing around with is configure await. And it's some stuff like when it comes out of that thread that gets it off the UI thread, configure await can tell it to just go back to any thread. To be fair, I didn't find any differences with this, because what I then started doing was wrapping this into the delay with the complexio all within this task, and called like this, even with configure await, you would get exactly what we see here. Okay, maybe I should show that. So that's with these. Alright, so complexio is within that task. I'll even put configure await, some nonsense. Well, not nonsense, I probably just don't understand it actually, exactly how that was supposed to do. So there is some functionality around configure await false. Apparently it tells it when it comes back to just use whichever thread it wants. It actually produces exactly the same result as the previous test. So let's have a look at that. Oh no, I'm wrong. Am I wrong? That came back quicker. It's a good job. Yes, indeed. Okay, so that, wow. I'm winning an award. This configure await used like this, my bad, actually does give the result. So sorry, rewind 3 minutes and just close your ears, because yes, configure await like this after the delay command here does then say what happened is this took us out of the we left the UI thread within this task using task delay into another thread. When we came back, we actually returned to the main thread, which would be the the Unity UI thread, the Unity main thread. But using configure await false, we took ourselves down to 659. So if we exaggerate it, we had a lot more, 10 times as much work. Let's have a look. Is that a freak result? 1741. Bear that in mind. How long does Invoke take? Invoke is still running, and that's the old result. Look, Invoke's taking ages. Invoke really slows down, as it should do, as we expected it to do, using a lot more work. There's 10,000 iterations of this complex factor square down thing function that we created just purely to slow it down with math. Now there we see 1741 to 11845. I'm going to actually write these down. Let's get that done. So we've got tasks. This is with let's just write it down. 1741 and Invoke 11845. See, without this work, if you looked at the last video, I'll give you a good feel for the overhead on well, actually, maybe this is better. I could try this with reduced work. It's a one iteration, 559. This actually makes it very close. There's a bit more overhead on a task. You can see the task has a start time, this call to the task, and the end time, wrapping up the task, is a bit longer also. And that's clear there. But add the work, and we're getting what we expect, milliseconds. 10 times faster, because it's multi-threading now. Okay, and what caused it to multi-thread in this case was this line after the delay. It's saying do the work, do everything after this configure await command within the task. Do it on a different thread. Just don't go back to the main thread. Use whatever thread you want, i.e. stay on another thread that you would have used for this delay. Totally makes sense. So okay, that does work, my bad. somehow convinced myself it didn't, but that works as it's supposed to. That's part, that's its function. The other way is to do this. This is it's not the same. When you do a task run like this, it's the same thing. That's saying force a new thread, create a new thread with task run. See, it's these task dot things that are creating the new threads. Task dot run is creating a thread, and then we're passing it. You can't just pass it the function, because it would say, wait for it. It's a system action. You have to convert it to a system action using this. Yeah. Okay, so task run now says create a new thread of this. See, we've removed configure awaits. Recompile that. Let's see if there's a different result or is exactly the same result. Theoretically, now actually that's doing the exact same thing to an extent. It depends if configure await has an overhead or not. Let's examine that. So we've got this. That was 1,000. I think it was set at 10,000. You got to press play again. So I think those results when we really slowed down. I'll just try it 1,000 anyway. I think it was 649, 785. Wow, that's interesting. Is that random? Yes, it's exactly the same, I'd say, as using the configure await afterwards. Take it at 10,000, that'll give you a better idea of time. 1,064, which is better than what we had in the notepad. Actually, that was much quicker. Yeah, the Invoke is still running. It's gonna, same as last time. Invoke 11.849, 11.845. This is what I maybe got confused with. Task.run is actually working more quickly than configure await. Just wrapping the whole task as run is running quicker than the 1741. Let's try it again. No, I mean, this is an interesting thing. This probably aligns quite a lot with background tasks on my machine. I do have other stuff open. It's doing stuff, definitely. Yeah, I've got quite a bit of software running in the background. So that's locking up in different ways. I think I have like a task that pops up now and again. It uses a load of threads. The invokes, Unity single-threaded time. But we can see there that this is properly multi-threading as we expected to have with the tasks, and using a lot of mathematical computation. Yeah, it's 10 times faster just using this construct. We could go back and test one more time. We'll run a few extras. Configure await post the delay. So very similar. Is it exactly the same? Because those were more like 10 something. Task.run. So we did compile that. I keep trying these a lot. Sometimes, I run to a server as well, man. If you forget to run that in, it can drive you crazy. You're trying to debug it, and you've saved, and you got like a parallel server Unity running. If you forget to re-import these sometimes, and then if you have it auto recompile every time, that would be worse. So let's have a look. There's almost like a weird theory. No, it's the same. This is exactly the same. That's it. Maybe even quicker, if anything. Just depending on what I got. That's completely locked it now. Invoke has actually locked the UI. That's worth noting. With a lot of work, Invoke is not creating a separate thread, it is locking. I think it's locking. It's acting a lot like it's locking. We're just waiting for the invoke to finish. There it goes. So, let's try this shorter one. It's certainly locked the edit. Yeah, it's locked the UI. Because, yeah, it wasn't getting the highlight click. Do you see what I mean? So, yeah, if it's doing a lot of work, Invoke is locking your... But bear in mind, it's not locking it with the timing. It's locking it with all of this heavy math. So heavy math, more than Invoke, heavy math is blocking your UI thread, your whole editor. And it would block your game if you had it doing something stupid like the 10,000 iterations of this complex sum. Then, yeah. But the task is completely not blocking it, running much quicker and not blocking the main thread of Unity. So it's great, actually, in this very simple example. If you were running this kind of heavy math, for whatever reason, obviously, quite soon I'll put the next step, which is the job system, which kind of creates threads, possibly in a better way for this kind of thing. That our next step, I think we can say without a doubt that yeah, because that's the 10,000 steps now. This would be like 11,000, at least 20 seconds. We can say without a doubt, it should actually have like how many steps there were in each, next to each statement of the results. There we go, that's the difference, 10 times quicker with that amount of work. And it's not locked up because it was multi-threaded, which really makes you think that you using the tasks like this, you're not locked and you're computing heavy math. So that's one to think about. Yeah, I mean, mostly used for things like asynchronous files, etc. But it's worth seeing that this, either you have this, configure wait after the delay statement to tell it to come back to any thread, not if you don't have that, it comes back to the main thread and locks it again before it does the work there. Or you just don't worry about that because you might not have a delay in it like that and you just want to run the work asynchronously. That is telling the task system to create a new thread, not just a new task, an async task. It's creating a new run. Task.run is creating a new thread to run the task in. Okay, great. So thanks for watching. Bye.